Hello everyone, welcome to this video series on cryptography and network security lab. So today we are going to look at program 12. So before that, like and share the video and also subscribe to my channel for notifications of latest videos. So this program is about generating a message digest using SHA1 algorithm. So SHA1 is like a hash function. So first, let's look at what is a hash function. So as you see here, uh, a hash function takes some input and produces a value called hash. Okay, so the output of hash function is hash. Input is any text. You can give any length text as input, but it always generates a fixed length output, which is called hash. Okay, so the number of characters in the hash output will be same. Okay, so if you see here, in the second example, it is saying the red fox runs across the ice, and the value generated is this by the hash function. Okay, and in the third example, if you see here, this word runs has been modified with another word walks. Okay, just one word is changed, but the hash value is different, right? So even if you change a word, a single character or a set of characters, the hash value generated by the hash function is going to change. So what is the use of such functionality means? Such a functionality can be used in digital signatures for verifying whether you are receiving the data from the intended sender or not. It can be used for password storage. Okay, and it can also be used in secure communication protocols, right? So these are the applications of hash function. Now let's talk about the SHA1 algorithm. So SHA1 is an example for cryptographic hash function which generates a hash of 160 bits length. Okay, so this hash value is also called as message digest, right? Okay, so this 160 bits uh, is generally displayed in the form of uh, hexadecimal notation. So you know that each hexadecimal character is represented using 4 bits. So when you divide 160 by 4, you are going to get 40 hexadecimal characters. Okay, so the hash which is generated by SHA1 is going to contain 40 hexadecimal characters, which will be equal to 160 bits, right? Okay, so SHA1 was published by NIST in 1995 as a part of secure hash standard, and SHA1 is a one-way function, right? So I will tell you what is meant by one-way function. So different properties of SHA1 algorithm are: first one is collision resistance. Okay, so this is with respect to the security of a hash algorithm. Not only SHA1, uh, all the popular hash functions or hash algorithms will have the collision resistance property. That means an attacker or adversary cannot find a pair, let's say x comma y, which will produce the same hash value. This is called collision resistance. Okay, so even if the attacker already knows x, the attacker cannot find y, which will equate to the same hash h. Okay, this property of hash function is called as collision resistance. And next one is one-way function. Okay, so one-way function means, let me take you back to the previous slide. So the hash function can convert the given input to a hash, but the reverse is not possible. Okay, that means once you have this hash, you can't find what is the text that generated that hash. This is called one-way property. Okay, one-way function or one-way property. And as I told you, the SHA1 algorithm is going to generate a hash value of 160 bits. Whatever length of plain text you give as input, it is going to always generate a hash value of 160 bits. So this is the internal structure or overview of SHA1 algorithm. So let me say one thing. Uh, I am not going to explain the inner details of SHA1. So I am going to just explain this overall structure. That's all. Because every hash function or hashing algorithm is very complex. There are a lot of things that are happening inside. They are even more complex than the cipher algorithms. Okay. So you have already seen block ciphers like DES, AES, etc. Right? Um, these hash functions are even more complex than those ciphers. Right. So here is the message that you are going to give as input, the plain text. Um, so if you see here, the SHA1 is going to operate on 512-bit blocks. Okay. If your message is less than 512 bits in length, the algorithm is going to pad pad the message so that it becomes a multiple of 512 bits. Okay. uh, and from this padded message, um, the word constants, or you can see here, the round word constants are going to be generated, wi. Okay, if you see here, these word constants are going as input to the rounds. Okay, so in total, how many rounds are there? 80 rounds are there. Okay, there are 80 rounds which are uh, grouped into four groups: round 0 to 19, 20 to 39, 40 to 59, and 60 to 79. There are total 80 rounds. Okay, and for these rounds, if you see, one input is this round word constant and another input is round constants. You can see here ki is the round constant. So this ki, these things are predefined values. Okay, pre-computed or predefined constant values. They are not going to change. Right. And you can see here, before all rounds, initially, uh, there are five vectors: A, B, C, D, and E. So the initial values of A, B, C, D, and E are also fixed. They are constant values. Later, when they go through these rounds, the values of A, B, C, D, and E are going to change. Okay. And once the entire process is completed, that is 80 rounds are completed, uh, whatever values of A, B, C, D, E you get here, they are added with the initial values of A, B, C, D, and E again. Okay, mind you, these are changed values of A, B, C, D, E, and this arrow is the initial values of A, B, C, D, and E. We add both of them, and this is MPX means multiplex. Then we move on to the next block. So if your input contains more than one 512-bit blocks, the algorithm is going to again continue with the next block. If there is only one block, this is not going to happen, and the output will be generated, which is the digest. This is the hash, which is also called message digest. Okay, so this is the overall structure of SHA1 algorithm. Actually, there are more complex operations which will be happening in these individual rounds. So we are not going to look at all those things. Just learn this overall structure, how SHA1 works. That's enough. Okay. So that's it about SHA1 algorithm. Thank you.